next topic is going to be on scientific notation. Scientific notation, the general form of that is going to be a times 10 to the b power. But why would we want to use this? What will be the point of doing this? On our previous problem, you noticed we had several things that had all sorts of zeros on them, made it very unwieldy to write down. Something like our last one where we had to have 6 zeros or 7, however many zeros we had there, 5 zeros, before we got to some non-zero digits. A lot of numbers in science are either extremely large or extremely small, and as a result you're going to end up writing out all sorts of zeros unless you use something like scientific notation to condense it. For scientific notation, there are a couple parts. The general form is a times 10 to the b power. The first one here, the coefficient out front, that's a. It has a value which is always between 1 and 10. So it is always between 1 and 10. So it can't ever be anything that's smaller than 1. You couldn't have a number out front that was 0.8 or 0.6. And it can't ever be larger than, it can't be 10 or larger. It couldn't even be 10. It could be 9.99999 because that number's smaller than 10, but it couldn't be 10. Couldn't be 10.1. Couldn't be 33. It always has to be something that falls with one digit, then a decimal point, and then maybe some digits afterwards. The next part is going to be the coefficient. That's b right out here. Is this number could be anything, basically any value as long as it's a whole number. So b has to be a whole number. You're not going to have something like 3.4 times 10 to the 7.6. You could have 3.4 times 10 to the 7th, or 3.4 times 10 to the negative 7th, but or 7, or even 10 to the 76th, but you would never have 10 to the 7.6. Below we'll see some examples. You see our standard form over there on the left. I have 13.4 for the first one. Now, in this case right here, the first question you'd want to ask is, look at what's on the left side of the decimal. Is it between 1 and 10? It's 13 right now, so it's not. We're going to have to convert this. Where do we have to move the decimal to get it? So that the first digit, it's one digit, then a decimal. Well, it looks like we have to move it over one spot. And since we have to move it over one spot, that means that we're going to have something that's 10 to the first power. And so we shift this over, and you can see on the right, 1.34 times 10 to the first power, because we shift over one spot. For our next one here, 450,000, well, where do we put the decimal? Well, let's put the decimal right there. How many spots did it have to shift over? There's go 1, 2, 3, 4, 5 spots. And so this is going to be 4.5 times 10 to the 5th because it's shifted over 5 spots. First two we've done here have both been numbers that have been larger than 1. This next one, 0.00991, is smaller than 1. Since the number is smaller than 1, it means that the exponent of 10, the power it's raised to, has to be a negative number. It's going to be a negative exponent. And so in this case, if we wanted to have one non-zero digit first, the decimal place is going to have to move to right there. And so how many spots do we have to move it over? We have to go over 1, 2, 3 spots. But since it's less than 1, it's going to be 10 to the negative third right there. And so that's what we've got there. So it's going to be 9.91 times 10 to the negative third. Our next one, also smaller than 1, so we'll have a negative exponent. How many spots do we have to move over? We have to go over 1, 2, 3, 4, 5, 6, 7, 8, 9 spots. So this would be 3 times 10 to the negative 9th. Similarly, on our last one, we have 2.34. How many spots do we have to move it over to make this number between 1 and 10? Well, we've actually already got it between 1 and 10. It's 2.34. So this is one where writing in scientific notation may not be very helpful because it really makes the number a lot larger. But if you have to write in scientific notation, you do it like this. You have 2.34 times 10 to the 0 power, because 10 to the 0 power is 1. 2.34 times 1 is just 2.34. And so that's basically what we've got for our scientific notation.